Hi, I'm following along with Paul McWhorter's Raspberry Pi lessons. We're on number 5, Understanding Binary Numbers. Paul gave a great description of how binary numbers worked. It was a good refresher for me. I already knew about them, but it was a good refresher. So he gave us homework to wire up 5 LEDs up to 5 pins on the Raspberry Pi and program it, use the LEDs to count up to 31. I'd already seen member Charlotte on here, follower Charlotte, already did it with modulo math and a few loops. And I said, man, I can't improve on that. She did a great job on that. I said, maybe I'll try a different way of doing it. Also, I come over from the Arduino world. So on Arduino, we have what they call port manipulation, where you can go in and set a whole bunch of LEDs all at the same time. I said, I wonder if Raspberry Pi has anything about that. Well, I went over to the GPIO documentation for Raspberry Pi for the library, and lo and behold, down here in the right at the near the number 4 on the list was how to output several channels at the same time. So you can give the output a list and a list of values as well to do that. I said, oh, that's interesting. So we know we can use binary numbers, display binary numbers on our output. I said, I wonder if we can take that binary representation and turn it into a list. So I played around for a little while and came up with a fairly good solution. Let's go to my code. So it ended up only being about 12 lines of code to get it done. So first thing I did was set up a list of the pins. So as you can see, we're using 5, 6, 13, 19, and 26. They're all in a row. And then they're all connected with resistors, and then everything goes back to ground. So that was easy way to get the list. And then, like I say, we're in BCM mode because we're using our cobbler there. So so we can use the setup, and we can set up all the pins at once with this lead pin with this list. So that was a really good find. It made it a lot easier. Didn't have to loop through it or anything like I did in the past. So that was great. You can set them all up in the list. Then I just set a loop, count up to 31, 0 to 31. And then what I did is I said, well, we want to display them as binary numbers. So we took the number and we're doing a binary representation of it by doing this inside part here. And then this next part turns it into a list. And if you had display a binary number, it's going to have 0 and B as the first 2 characters to designate it as a binary. And we didn't want that, so we took off this format takes off the first 2 characters. So we end up with a list. So that's okay, but the low numbers, you're only going to have, like if you have the number 2, you're going to only have, it's going to be 1, 0 or 1, 0 once it's in the list. Plus this list is also a text item, so we had to also address that also. But we needed to get up to 5, make sure we had 5 characters, exactly 5 characters in our list, because sometimes you have less and sometimes more. But this next line takes care of that. So we're starting off with 4 list items, and then we're adding it to our actual list up here. And you do list comprehension to get them into a, to take out to change them from text to integer. So for int I and b, we're going to make it an int. So it's going to change it over to int. So we're adding these two together, and that's why I got the parenthesis out here. So we're adding 0, 0. So you could end up with, with ours 5 and 4 is 9 characters. But you could also end up, if you only got a 1 in here or a 0, you could end up with just 5 characters. So what we do is, we know we're going to have at least 5 characters, but we only want the 5. So this -5 gives you the last 5 items in the right hand 5 items in the list. Hope I made that clear. But anyhow, that's the way that one line of code works. It's going to ensure that you're going to get a binary representation of a binary list of integers, 1s and 0s basically. And so we end up with that list. So then all we have to do is output our list of lead pins, and we're going to output so we're output the list of values to the list of pins. When I wrote there, it made it a lot more clear than what I just said. Anyhow, so that's it. We're going to sleep one time, and we're only going to go through the list once, and then we're going to stop and clean up. So let's go ahead and run it and watch it do its thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Yay! Anyhow, quick and simple, this code, just 12 lines of code, got it done. And I got a feeling nobody else is going to do it this way. So I like to be an odd duck in the programming world anyhow. So thanks for watching. Paul, thanks for all you do. Bye.